Just a quick recap on the basics that are important for understanding the formation of line thunderstorms. A front is a boundary of separation between warm and cold air. All fronts are characterized by cloud and subsequent rain. The movement of air or wind from an area of high pressure to an area of low is called the pressure gradient. Pressure cells that are caused by intense heating during the summer months, especially over South Africa, these low pressure cells are called thermal lows. The important influence of the anticyclones or high pressure cells off our coastlines. The South Atlantic high pressure feeds cold and dry air towards the country from the southwest, while the South Indian high pressure feeds warm and moist air from the northeast. Before getting into an explanation of how line thunderstorms and moisture fronts develop, it is important to be able to define what exactly they are. Line thunderstorms are thunderstorms or thunder showers arranged in a line from the northwest to the southeast of the interior of South Africa during summer. A moisture front is a boundary of separation between air with different temperatures and different moisture content. This moisture front separates warm and cold air, but also air that is dry and moist from each other. A number of conditions are required in order for line thunderstorms to develop over South Africa. Firstly, they develop during summer and they occur in a straight line running diagonally across the interior of the country from the northwest, running all the way to the southeast of the country. During the summer months and intense heating over the interior of the country, the thermal low or the heat low needs to develop over the interior of the country. Along with the thermal low over the interior, we need the presence of the South Atlantic high pressure and the South Indian high pressure. The presence of the low over the interior and the high pressures over our oceans will set in motion the pressure gradient force that is going to compel wind to move from an area of high pressure to an area of low pressure. The South Atlantic high pressure cell supplies the cold and the dry air needed for the development of moisture fronts. As the movement of air around the center is in an anti-clockwise direction, this cold and dry air approaches the interior of the country from the southwest. The South Indian high pressure supplies the warm and the moist air required for line thunderstorms. The anti-clockwise rotation around the center means that this warm and dry air then approaches the interior of the country from the northeast. The warm and the moist air and the cold and the dry air will converge onto the low pressure at the interior of the country, thus forming the formation of this moisture front. Bearing in mind that a front is a boundary of separation between cold and warm air. In this case, the green line represents the moisture front, which additionally to the cold and the warm air being separated, it also separates the dry and the moist air that have come off our respective oceans. When these two air masses meet along this moisture front, the cold air typically sticks to the surface of the earth and the warm air is forced to rise up the front. Hence, thunder showers and the majority of the rain falls on the eastern side of the moisture front as a result of the eastern side being where the warm air approaches from, but also the side on which the warm air rises and cools down and condensates and then produces rainfall. So, quick summary of what is required. Low pressure over the interior of the country, cold and dry air from the southwest that is coming from the South Atlantic high pressure cell. You need warm and moist air from the northeast that is supplied by the South Indian high pressure. Those two different air masses will meet at the interior of the country to form what is called a moisture front. Your cold air on the west sticks to the Earth's surface. Your warm air in the east rises up. This front produces cumulonimbus clouds and hence produces the thunder showers, lightning, and the heavy rain that is associated with these thunderstorms. All of this will occur on the eastern side of the moisture front. Let's have a quick look at how this content was tested in paper 1 of November 2024. The extract reads as follows: line thunderstorms over South Africa. During summer, thunderstorms can form a line that can extend for hundreds of kilometers. These line thunderstorms can persist for many hours and produce damaging winds and hail, which impacts negatively on the natural environment. Question 1.5.1 reads, according to the extract, in which season do line thunderstorms commonly occur? This means that you need to actually find the answer in the extract, and the correct answer there would be summer. 1.5.2, describe the temperature and moisture content of wind A and wind B that led to the formation of the line thunderstorms. For this question, it's important to distinguish which is which. So you have to say something about the temperature and moisture content for wind A and then the temperature and moisture content for wind B. So if you look at the diagram, wind A blows off the South Atlantic high pressure, which means that wind A is cold and dry. Wind B originates off the Indian Ocean from the South Indian high pressure, and so wind is warm and moist. 1.5.3 says to explain why the heaviest rainfall occurs closest to the moisture front as evidenced in the diagram. So if you have a look at this part of the diagram, it shows you the moisture front, and it shows that closest to the moisture front the rainfall is heaviest, and further where you move from the moisture front the rainfall decreases. And the reason why it is heaviest closest to the moisture front is because there is a fast and rapid uplift of the air, and because this air cools down so quickly, it produces heavy rain. The condensation happens over larger vertical extent closest to the moisture front, and therefore the rainfall is heaviest. And very important, closest to the moisture front, there is a thick band of cumulonimbus clouds that develop, and these cumulonimbus clouds specifically produce heavy rainfall. So the reason why the heaviest rainfall is found closer to the moisture front, there's quick uplift of air along the moisture front. Condensation occurs over great vertical distance high up into the atmosphere, and there's a thick layer of cumulonimbus clouds found closest to the moisture front. Question 1.5.4 says to explain the negative physical and natural impact of line thunderstorms. As a geographer, it is very important that we realize that geography is not studied in content, in isolation, and for that matter, in our study of geography, especially at the grade 12 level, we are very interested in how these geographical phenomena impact us as humans, and how we are impacted by them in turn. So this question focuses on how these line thunderstorms have a negative physical or natural impact. Uh, so I'm going to take the answers directly from the memo, the official memo for November 2024, and the following slide does have the answers I'm about to share. So natural habitats will be destroyed, ecosystems will be destroyed, biodiversity will be reduced, topsoil will be washed away, leading to soil erosion. Mass movement, which you learned about in grade 11, can be triggered. Wildlife can be displaced, or the wildlife can drown. Trees, natural vegetation can be uprooted or destroyed. Water quality will be reduced. Increased leaching of soil. Sinkholes can form. Setting up or deposition of material. In question 1.5.4, it is important to remember that most of this damage results from the heavy rainfall that is associated with these line thunderstorms, and very often the heavy rainfall produces extensive flooding. Line thunderstorms are also accompanied by lightning and thunder.